And this will be classwork 3.2, number 21, the last one. Okay, so this problem says a pilot performs an evasive maneuver by diving vertically at 310 meters per second. So they're going straight down like this at 310 meters per second. Okay, he can withstand an acceleration of 9 Gs. 9 Gs. What does this mean? 9 Gs means 9 times gravity. Okay, if you experience a G-force, okay, it means that you are experiencing a multiple of your own weight. So when you experience 2 Gs, you feel twice your own weight. So you can imagine like the pushing on your chest that makes that you feel. Or if you experience 3 Gs, it's like 3 times your weight. So the maximum that he can withstand is 9 Gs, which is huge. Okay, so it's actually 90 meters per second squared. Okay, and remember that this is centripetal acceleration. Okay, now it says at what altitude would he have to begin to pull out of a dive to avoid hitting a crash? Okay, so as a pilot sort of pulls out, like whatever they do, I don't know, they pull back on the steering stick or whatever. I have no idea about planes. With some of the flaps on the side of the plane cause some sort of force or friction between the air and the plane, which causes it to turn. But the point is that immediately when you begin to pull out, you begin to exert a force that will give you an acceleration of 90 meters per second squared inward. Okay, which will cause the plane to arc around like this. Okay, and the radius of the arc would be equivalent to the height that you are above the water. So really what we're trying to find is just this height here, okay? And we don't have a force. The force doesn't matter because we're just trying to find the centripetal acceleration, which is equal to v squared over r. Or we're trying to find the r given the centripetal acceleration. So force doesn't matter. Our m doesn't matter, okay? So centripetal acceleration in this case would be 90 meters per second squared. We know they're going 310 meters per second squared, or 3 meters per second. We're going to square that, and that will give us the radius of the arc, given that immediately we would have 9 Gs of force, and they'd be able to turn that way. Okay, so you're going to have 310 squared divided by 90. Oops, 310 squared divided by 90. Gives us 1,068-ish meters. So the radius would be 1,068 meters above the surface is where that plane has to start an acceleration of 9 Gs in order for it to arc out and just miss the water.